Hey y'all, welcome to our 6-2 video. This is multimole ratios. This is page 6. Please make sure you get the essential question there. What is a multimole ratio? And how can it be used to solve stoichiometry problems? So jumping right in here, I went ahead and gave you the definition of what stoichiometry was, because this is what we're going to be using this whole unit. Stoichiometry is using a balanced chemical equation to convert between substances. All right. So let's take us back to our grilled cheese example. Hopefully you remember our grilled cheese example from last unit. All right. So our grilled cheese, we said that 2 slices of bread plus 2 slices of cheese plus like a quarter of butter yields 1 grilled cheese. Hopefully you remember that. Now, if I were to ask you how many pieces of bread would I need to make a grilled cheese for 25 students, you would quickly say 50 slices of bread. But let's talk about that in terms of the multimole ratio. So if I need 25 grilled cheese, right? I know that for each grilled cheese, I need 2 slices of bread, which is where you got your 50 slices of bread. All right, you did this really quickly, but this is a multimole ratio. You know, for every grilled cheese, I need 2 slices of bread. I also need 2 slices of cheese, all right, and so on. So let's jump into our multimole ratio. This relates two substances in a reaction. Awesome. So let's go ahead and go through our steps of stoichiometry. Today, we're only going to be talking about 2 steps, but we're going to show all 4 just so you know what they are, and they're not going to be different when we introduce them to you. So here we go. Step 1, write a balanced chemical equation. Step 1, write a balanced chemical equation. Step 2, find moles. This is an if necessary step. Sometimes, like today, you will already be at moles, so you do not need to do that step. Step 3 is our mole to mole ratio. Just like we did up above, we used our balanced chemical equation. Another way to think of this is where are you going over where have you been. We'll talk about that more as we get into this. And last but not least, our last step is going to be to find grams. And this is an if necessary. Okay? Find grams if necessary. All right, so let's see if we can't do this. And our first step is going to be to write a balanced equation. So we're going to need some different colors. So please grab out a couple of different colors. You need 3 to be exact. All right, let's break this reaction down here. First off, using our neutral color, how many moles of oxygen is what we're looking for. So we're going to circle that. Are needed to react completely with 10 moles of hydrogen. And that's really all that's given to us. So our first step is going to be to write that balanced chemical equation. So pick up a color. I'm going to go with blue. All right, and we have O2. Right? Whenever oxygen is by itself, it is O2. All right? It is going to be reacting with hydrogen. So please pick up another color, H2. At this point, we have to kind of figure out what is going to be the product and keep it simple. So the simplest thing that we can form here is H2O, water. Miss Griffith forgot to change her color, so please erase that. Please pick a different color. I'm going to go with purple. Hopefully it's not too perfect. It's different enough that we can see it. So now our balanced chemical equation, we're going to put a 2 in front of the H2O. Please still keep it in that color. All right, we're going to put a 2 in front of the H2, and we're going to put a 1 in front of the O2. So this is our balanced chemical equation. Going back to our neutral color now. All right. We know that we have 10 moles of hydrogen. So on our T-chart, we're going to start with 10 moles of hydrogen. Whoa, whoa, whoa. Now we're ready to go ahead and do our steps. Step 1, write a balanced equation. Step 2, find moles. Miss Griffith, we're already at moles. Awesome. Step 3, we're going to do our mole to mole ratio. This is where we're going to put where we're going. What are we looking for? In this case, moles of oxygen. So on top, in blue, I'm going to put 1 mole of O2. This one came from that one right there. On bottom, I'm going to put where I've been or what I started with. In this case, I started with hydrogen. So I'm going to pick hydrogen's color, that pink, and I'm going to put 2 moles of H2 on bottom. Notice how moles of H2 cancel. Our last step says to find grams if necessary, but it wants us to find moles, so we are done. So to solve this T-chart, we're going to multiply across the top, divide by what's on bottom. 10 times 1 divided by 2 is 5 moles of O2. All right, pretty easy stuff, hopefully. We are going to continue using this reaction, so I'm going to circle it and move it right down here because this reaction is going to stay the same. All right. And let's look at this one. All right. So we have moles of water. I don't know why my circling is not working. All right. And we have 2.50 moles of oxygen. So this time on our T-chart, we're going to start with 2.50 moles of O2. And we're looking for moles of water. So on top, we're going to pick out our purple one, the 2 moles of H2O, because that is what we're looking for. We're looking for water. And the 2 came from our balanced chemical equation. On bottom, we're going to put what we started with. In this case, it was that 1 mole of oxygen. Again, this came from our balanced chemical equation. Anytime we do our multiple ratio, it comes from the balanced chemical equation. We are done, so we're ready to calculate. 2.5 times 2 divided by 1 is 5. Miss Griffith made 2 of them be 5. I apologize for that. Maybe we'll change that. All right, awesome. I would like you to please work this third one on your own, so please hit pause, all right, and give it a shot, and then see how you're doing as we go. This time, our answer was not 5. Hopefully this made sense to you. See you next time.